What if I told you light isn't just a stream of particles, but a wave that dances? Welcome to Physics in Motion, where we unravel nature's deepest secrets. Today, the experiment that changed physics forever. In 1801, Thomas Young asked a revolutionary question: could light interfere with itself? His brilliant experiment, two tiny slits, a beam of light, and a screen, revealed light's hidden wave nature. Here's how it works. A coherent light source, like a laser, strikes a barrier with two parallel slits. As waves emerge from each slit, they spread out, overlap, and create a stunning pattern on the detection screen. Bright bands where waves add up, constructive interference. Dark bands where they cancel, destructive interference. The key is path difference. When light travels from two slits to the screen, one path may be longer. We call this delta, the extra distance. For small angles, delta equals slit separation d, multiplied by sin theta, which simplifies to d times y over d, where do bright fringes form. When the path difference equals a whole number of wavelengths. Mathematically, delta x equals m times lambda times d, divided by d. Here, m is the fringe order, 0 for the central maximum, 1, 2, and so on. Lambda, wavelength. D, screen distance. D, slit separation, but darkness has its equation too. Destructive interference strikes when the path difference is a half-integer multiple of wavelength, delta x equals open parenthesis m plus 1/2, close parenthesis, times lambda d over d. Perfect cancellation, and here's the magic: theory meets reality. The equations predict exactly where bright and dark bands appear. The interference pattern isn't random, it's mathematics made visible. So what did Young teach us? First, light behaves as a wave, creating interference like ripples on a pond. Second, these alternating bands aren't accidents, they're wave signatures. Third, math doesn't just describe nature, it foresees it. And finally, this simple experiment cracks open the door to quantum mechanics, where light reveals its dual soul. From photons to black holes, there's more wonder to explore. Hit subscribe for journeys into the quantum realm, relativity, and beyond. Question with us. Share your curiosity. This is Physics in Motion.